Alright, so I got altitude hold working, but what a pain it was. Wow. So turns out there were quite a few issues, and the first one I alluded to, which was the barrow is very exposed, and it's here. And so what I ended up doing in the end was putting a piece of foam over it and then a bit of foam tape over the foam just to sort of avoid the prop wash. But it turns out these little copters, I don't know how common this is, but certainly on this one, this is a little bit like a ducted fan. So these are very high kV motors. I think they're like 7,000 kV or something. Spinning very fast. The airflow is very close to the barrow that's here, and you've got this sort of fast moving column of air coming here, and that's creating a vacuum here essentially. And interestingly, the faster these motors spin, the bigger the vacuum. And what I discovered through a lot of trial and error is it's pretty much linear with throttle, so it's proportional to the throttle. So what I did was I wrote a little change to the barrow driver that basically allows you to apply a scaling factor proportional to the throttle. And I found that then, because what I was discovering was as soon as the motors were on, you got this big offset in the barrow, and the higher the throttle, the more the offset. So I wrote this change that allows you to sort of set a scaling factor that is applied based on the throttle, and a little bit of trial and error to find out what that good value is, but you can sort of determine that from the logs, and that worked really well. So I got the barrow actually giving somewhat reasonable estimate in height. So it was saying I was sort of 5 meters off the ground when I was more like 1 meter off the ground, and so with that change I was able to get to the barrow to give the right estimate, but it still didn't work. So I was still having issues with EKF, and what I found was that the IMU was registering this sort of offset when the motors were running of a particular gravity. And usually that indicates vibration. So what I did first was I noticed that this power and UART connector for the HD transmitter was actually touching the prop frame. And so that was transferring vibration. So what I did was I put in, and you probably can't see, but I put in an extra M2 nylon washer between the prop shrouds here and the standoff screw. Just that extra couple of mil then raises this above that, so it's no longer knocking. So the next thing I discovered was that the TBS receiver was also knocking against the frame, and so what I've done to that is I've wedged a piece of foam underneath the TBS receiver here, just to provide a little insulation, because the TBS receiver doesn't need to be connected to the IMUs. It could be, I mean, ideally if I could be bothered to take this apart yet again, I'd probably try and sort of glue it or attach it to the frame this side so it's clear. But for now I just stuffed a piece of foam underneath, and that seemed to work pretty well. And then the final thing I did was I used the fast rate code. So one of the things I found with these little copters is they need everything to be very reactive in order to be able to be controlled effectively. And I think because the frequencies are so high, it's easy to get aliasing. And so if you got aliasing, then what you want to try and do is raise the sample frequency of the IMUs. Now, there's a setting to do that, but the problem is as soon as I did that, I immediately ran out of CPU and I had it sort of hit the ceiling a couple of times. But this is where the fast rate loop comes in. So what I can do with the fast rate loop is I can raise the sample rate of the AMUs, or sort of lower the sample rate so it's going faster, but at the same time lower the main loop rate to sort of compensate. And so what I've ended up with is quite a nice setup where the gyros are running at 2K. There's only a single IMU. Gyros running at 2K. The fast rate loop is running at 1K, which is still a lot faster than the main loop would be. And then the main loop I'm running at 200 Hertz, which is, way down and buys me lots of CPU. I could try fast loop at 2K, but it's sort of borderline. Anyway, that's what I've ended up with. And miracle of miracles, I now no longer see these enormous EKF innovation spikes in the height estimate, and in particular I don't see this sort of fixed offset of acceleration. The EKF doesn't think it's accelerating up the whole time, and that means that alt-hold now works. So I also sort of found a few bugs in the Baro driver for the SPL06, which I'll fix as well. So I'm going to put up a couple of PRs to solve these. But yeah, that was sort of 2.5 days work in the end, a long and arduous process. But I do have alt-hold working now, so I'm hoping that maybe I have a chance to auto-tune. So good stuff.